That's good. Yeah, okay. Good. So thanks. Yeah, last time we talked about temporal NLP processing, temporal summarization. I have just a few slides to finish summarization, and then we start about temporal information retrieval, IR topic. And do you think it's fine? Can you hear me online? Something changed here, but I hope I am audible. Okay. And then we'll talk about temporal common sense also analysis. Good. So just to tell you that, well, we had timeline summarization last time discussed, but community is also proposing many variants of temporal summarization. One of them is real-time summarization. The idea is quite simple. Imagine you are, let's say, having a continuous meeting with company officials, and then there is a break, let's say a week, and then again the meeting, and a break, 1 week, and again a meeting. And you want to kind of summarize each time what happened. So it's a real-time summarization. The stream is coming, and then a stream of meetings, let's say some discussions and so on, and then you need to create a summary, and creation of the summary is based on what was before discussed, right? So it's sort of like, because not everything will be spoken at the meeting, something is shared and has been already established before, and that knowledge may be utilized for creating updates each time there is a meeting. But it's not only a meeting, it could be a stream of tweets coming, and then you need to summarize it and again summarize it and update, send a short update, let's say by email to the user. I will not show results here. I just mentioned that it was established on a well-known competition track, which is like SAMEVAL or CLAY, that shares data, organize evaluation, shared style, and then teams submit from the Word, and we select the best one usually. And there are many topics on track, not only, of course, real-time summarization, but it's one of them. And then this is the last summarization I want to talk today, which is very interesting because it's future and actually very under-researched topic. To my taste, it's future event prediction is something that we continuously actually do. We as humans are every day forecasting what we will do today, tomorrow, next week, and planning all the time. It's natural. It's a human activity. However, surprisingly, there is little done on summarizing data that is about future. And it has its own challenges, as you will see later on. We try to focus on this topic and even use LLMs to see what they can tell, how much information they have about future events of some well-known entities. And here, future timeline summarization will be created timeline, not only one event you predict, but actually you try to predict, of course, with confidence, with some rationale, you try to predict what can happen for a given entity or for a given maybe continuing developing event. And the interesting point is that on the web, we have a lot of opinions about future. We have speculations, we have expectations, we have forecasts, we have plans by different sources about, let's say, concerned entity. Let's say you want to know what is future of Toyota because you are investing in Toyota company. You would be happy to know that's a plan for, I don't know, building a factory somewhere, maybe in Rajasthan or Punjab or something. A plan to introduce new car model, a plan to introduce electric line of electric cars. But confidence, for each of these plans, and rationale, and also some conditionals, because, okay, something will be done if something else will be done. You want to know those conditionals. You want to summarize this data and have some probability. So I think for investing, for decision making, it's quite important to do this forecasting, but ultimately difficult is to do evaluation. Obviously, you know, no one can really predict the future, but we can say something about the future because we have a lot of data. So this research is increasing from somewhere like 2005. There was this future information retrieval paper by Ricardo Baez-Ayates. Then a bit more papers, so it's like stable over time. There's no peak or nothing, but there is a good number of papers that do something with future prediction based only on collective wisdom of users, and not like forecasting time series, not like some kind of temporal processes. It's just taking opinions about future and summarizing, such a future summarization. And I'm talking about it because it's of course temporal, and you can draw a timeline as well, right? And you have some data sets. There is no Hindi, there is only English mainly, and most of the time they are just they are no, how to say, yeah, very few grand truth answers. It's just collected data about future, but with little grand truth answers. So of course, unsupervised solutions are mainly done. And let's say, let's look at the example from the paper of Nakajima. And he posed the problem not even as a summarization, more like a question answering. So let's suppose you have the question predict, or well, the instruction, predict whether in 2020, because the paper was published 2 years before, nursing care fee will be applying AI in care planning, right? And then you have some options. So it's a multiple choice question, let's say, or instruction. And out of these, you need to choose. But you have some relevant sentences from data you can search. So it could be a search problem. Match those sentences to those answers and maybe see how often the statement like this is repeated in the data set. Not just once. If you see it many times, you have more confidence. Of course, many times from different sources. You don't want everything from one blog, one website. And we started writing a survey of this field, wisdom of the crowd for future. And we propose this model that any sentence about future can be decomposed into these characteristics. First of all, it's a timestamp. When you give forecast about the future, do you give it right now, or was it issued 1 year ago? The older it is from the time of now, the less reliable this statement will be, because things may happen, right? Second is modality. Is the future statement very strong, like Toyota will surely open factory, or Toyota may be open factory, might be, right? So the level of sureness implicit in a sentence that you can capture by NLP techniques would be this modality. Next is rationale. Does the statement has some supporting information, right? Toyota will establish the factory because, I don't know, because Rajasthan does not have any, or it has a lot of population, or something, right? So whether there is this rationale giving, and this rationale is giving the strength to the future statement. Then conditions. Well, Toyota will do this factory if the local government provides tax-free land or something, right? Is there a condition or not? We want to detect it. Of course, you need NLP to detect rationale, detect conditions, detect modality. Timestamp you might have been given, or you may need to actually calculate it. Then credibility of the source. Is it a government website, Toyota company website, or a blog of an unknown guy? The type of statement, and whether there is also some, of course, what event it is, what attribute it is, and here you can talk about the also date expected. Is it 2 years later that the company will be making a factory, or is it next month, right? So many attributes you can extract from a sentence like here, for example, and then quantify those conditionals, rationale, the timestamp, the expected date, and what to do with this. You later summarize many such future opinions and add some, credibility score, some expected date when it may happen, and so on. And this topic is not yet researched so much by community, despite it's so important for planning, despite we are actually as humans doing forecasting continuously. And we are evaluating rationale, conditionals, probabilities, everything in our mind. Why not to have AI to help us with that? I think this will be more and more important. Of course, we know evaluation of this is very difficult, but it's a summarization, essentially. You have multiple opinions and you need to summarize them, but not just considering the content, but considering all this modality, rationale, conditionals, credibility, timestamps. It's a kind of rich, I would say, type of summarization. Then we started researching this field. Well, this was just done with bachelor students, so not much done yet. It's still kind of new. And I asked him to make a timeline, a system for generating future timelines, actually. Something like here, this is so-called future wheels. It's one style of forecasting where you have some kind of event and you see the first consequences, then the further consequences of it. Of course, it's like a tree, but we still want to make it just one timeline for the most probable things. So we don't go into, this is the future, of course. We won't in the future create something like that, but we now focus on a simple timeline building. And the demo system that was built takes the query like Toyota or Lindia or Johnny Depp or whatever you want, retrieves the data about this person or this entity, pre-process it, removing something. And here is very important step, classifies future statements on this entity versus non-future statements, because we only want to summarize future statements. And then the rest is some kind of clustering, time tagging, and visualization. I will focus mainly on this part because, well, the problem is still new and we don't have a good way yet to tell, is this statement about future or not? Of course, you can say with the keyword will, he will, I will, but it's not always will. Sometimes you might have is planned to, is scheduled, is supposed to, is thinking about, a myriad of ways you can relate to the future, and it's not obvious how to do it. So we collected a data set of these sentences, partially manually, partially semi-automatically, even asking ChatGPT to generate some future sentences versus non-future sentences. Some of those sentences have temporal expressions, but actually many not, which is good. You don't want to have just future date. It will be too simple. And then we train a BERT classifier, which have reasonable good results. So we think the task may not be that hard to distinguish, but these are just basically news. You know, maybe our style of collecting data was not representative that much enough is the first work. So we are still building more data sets to have here. And this is the work done with some students from India, also bachelor, that created a bigger data set of 10,000 sentences, this time not from news, but from Wikipedia, about some entities. We had like people, locations, companies. We created a lot of sentence pool. And then from there, we actually, in an iterative way, we sort of use the previous BERT model as here, find some future sentences, include it into data set, and then retrain the model again, and again search for more data and retrain again. So it was kind of like a spiral. But in the end, we have 10,000 sentences, and here there are top verbs, top nouns in the future related sentences. Of course, there's a lot of announced, something stated, released, based. It's often appears, right? Agrees to do something, right? And this is that how you refer to the future, and here the nouns would be a lot of dates as we see, and some government and the country, because well, these are decision-making bodies. And then again, we tested some models, and we even tested a simple models like here as VM decision tree. They have a decent performance, and we confirmed that the task is not that hard. Using Roberta is an extension of BERT, but trained on a highly selected data and with good hyperparameter selection. So it's usually, if you want to improve over BERT, you use Roberta. You have often slightly better results, which we can also see here even, right? But the task is not that hard, which is good. We can collect a lot of future sentences about any entity. The task now to research is, of course, how to summarize it. The student did a simple, very simple approach, just use BERT topic, which is like topic mining, like you would do with LDA, but supported with a BERT. And then each timeline here is drawn with some events as a dots, and then you click on the event, and then you have some representative sentences selected, which another algorithm is for that. And then can pick up some top clusters here. The size of the font indicates how strongly the cluster is sort of repeating in the data set we collected, and it all goes for a query. So user can type a query, Toyota, the query goes to news provider. We extract a lot of recent news about Toyota, let's say, filter those about future, keep only those about future, and then do this topic modeling, detect the time, the common time for each cluster to position on the timeline, and so on and so on. But there's a lot of to be done here. And another student of mine, again, just bachelor, so we don't expect too much to be done, but started now researching, can LLMs say something about future? We don't expect them to, you know, fully tell us, but it can provide you some rationale. It can organize your options for the future. It can be still very useful because LLM was trained on a massive data, and obviously some future opinions were there as well, right? So we built a data set, and there were some existing data sets. It's not purely novel topic, but we built a data set, first of all, for the newest events. The problem with the future prediction is that once you build a data set, and you want now to test LLMs on this data set, you might have even answers because there was some kind of question, and later the question was verified if it really happened, but you have it on time, right? But LLMs are continuously updated. So the future LLMs you want to test already will know the answer. You can't really use them. We don't want to have LLM that already observed the answer to judge the question. So it's always important to continuously generate such data sets. And so these data sets here existing, they were not so good because the latest is until 2022. Now most of the models already are trained after this cutoff date. So we created on a more recent data, and we also supplemented each question with data such as when it was resolved, what's the publication date of the question, news article supporting this question, so giving some context for LLM to better answer the question. And we collected it from a website that gathers many future questions, actually post it, and many users try to guess the answer. It's kind of like some sort of betting on the future, and then the question finally is resolved by the author, says, okay, we know already who is the winner of whatever World Cup, or we know already who is the winner of some kind of competition, or then the next question, and there's like thousands of these future questions community likes to predict. We collected this data, and we tested then LLMs. It's not much, we only have 600 questions, but well, yeah, the problem is that it's quite time-sensitive data. And here we tested 3 models. So the large, and here is a cutoff date. It's very important now to pay attention until what data model was trained, not to have a contamination that the model knows when the answer was created. It should only reason on the question, should not see the answer. And we also tested, like, if we just give a question, can we have a good success rate? Because we already knew the answers. They were past questions with already resolved answers, although for the model LLM, they were still future, right? So we kind of made sure. You just provide a question, you have this success rate this, but if you provide background and the news article supporting, then LLM can kind of a little bit better answer. You observe it also in Alpaca, and you observe it also in Llama. And then you provide a rush, what is this R? I think it was requirements to resolve some kind of, from Meticulous website, more information, what it means, what it needed to resolve the question. Basically no answer, but always supporting context. And we observed that the more you provide to LLM, it's of course never perfect, but can give you a bit more, close to the truth answer. And here the problem we observe is that most of the time the LLM just said no, this will not happen. No, right? And this was just too many no answers. So we kind of manipulated the prompt, added more information to decrease this level of no's and have more, also equally yes. I don't know, maybe these models were somehow instructed to always say no whenever you ask about the future, right? But yeah. So I think this research is very promising, and just to make a good data sets, to evaluate many settings, what else to add, what kind of prompts to make, and how to maybe use prompt engineering, maybe ask first the model for rationale, then giving the rationale with the question, ask again the model to give the answer, then maybe pick up conditions that are needed for an event to happen, and again answer, and so on. So I will continue researching it, especially as community is still not yet on this. But now let me finish the part on summarization and move to a common sense mining with LLMs, and of course not only, and especially temporal common sense. So a bit different topic. We finish summarization. Common sense reasoning, and what's that? Well, we know that many models are somehow, not really operating against our common sense, right? You might have, this is a famous example, an image of panda, and then you add some noise, and even though LLM or some model labeled this as a giant panda, it was not LLM, it was just a simpler model. Now it's just with this noise in labeling as a gibbon. Or here, I don't know, cannot give the good number of these animals because of some, patterns. Here, the caption generated is about horse standing in the grass. Some kind of, trivial things. For example, here you have some information, and then the question is when Tesla where the Tesla move, and it says about Chicago, although this refers to another person, not Tesla. So some kind of, especially maybe at this time, and Tesla and Chicago, Tesla never traveled to USA. He was a Serbian researcher. So yeah, it's against some common sense. But this is close to artificial intelligence, the true artificial intelligence we want to build, or general artificial intelligence. And there are many psychological, discoveries or opinions. Some researchers like Kahneman says that we have, as humans, two types of thinking. One is this fast thinking. The book here is Thinking Fast and Slow. It's one of the famous books, widely read. And it says that many of our thoughts are this kind of very fast, intuition-driven, almost unconscious, associative also, not logical, not reasoning as it would be on this system 2 type of thinking, which is more rational, which is slower, which is more difficult for us, but is operating just in another way, logical and so on. And then where is AI? Well, according to Kahneman, AI is more on this side, somehow associations, some kind of shortcuts, rather than those very well logical reasoning and so on. Well, it's debatable. Are we really generating AI for that system or for this one? Nevertheless, this is well known as theory, and we're studying more. If further studied this system 1 into system 2, that you have here perception and intuition, then it's system 2, which is slow, controlled also. You can control it, but effortlessly by your mind, but you can't really control these things. These are so prime in us, or I would say even primitive, from ancient times developed. We can't really control them. Anyway, very interesting. But what we really, care about in terms of NLP is, can we solve some task, common sense reasoning task? Can we say that if we have these strings here, we can tell that, angry was before, and then police used the gas after, and this is a cause for this demonstration, and all these common sense things which are implicit and may not be stated in text, right? Can AI, can we do that? And that's the question. Maybe even you have a more harder case where this statement is first here and the other statement is following. But from common sense, we know the order should be opposite, right? We cannot just make an order like here. And common sense reasoning is not about time only. It's about anything. For example, can we say that you may open the door of a fridge and keep it open, or you can open the door of a room, right? And common sense tells us one is possible, one is not, and keep it for a long time. Or can we build a bridge to the moon or a tower to the moon? Or can we, do something that doesn't make sense, like store elephant in the fridge, again, the fridge example, and so on and so on. So this is a hard task. As a community is working on it, I only focus on temporal common sense and temporal relations, but you can imagine there are other things like spatial, cultural, many other of common sense reasoning. It is more AI topic, but NLP is now telling a lot on that as well. We'll focus on the temporal the common sense reasoning. Something like, okay, you might have a text like here, you can build a graph, you can build connections, but important is, can you establish directions with what action was followed by what other actions? That would require a lot of common sense, especially if you don't have the style of writing reflecting what was actually the order. And in narratives, in literature, you have retrospective opinions, stories. You have mixing different episodes, not along the timeline, normal timeline, and so on and so on. So it's not that simple. Not only ordering is important, also the change. How long was Obama senator? How long he was president? Three spouses having, how long it lasts? Does it mean that these three spouses may change tomorrow or 1 second later? Not really, right? We know this is a long-term, a more stationary relation, while others are not stationary. This also relates to maintaining knowledge bases and knowledge graphs, which have to be, updated, keep up to date, and you need to revisit some facts, recheck if they still hold in the supporting data, and also give some temporal scopes for facts, especially past facts that already cease to exist, but we want to know when they started, when they happened, how frequent they are. There is a lot of temporal information. And as I said, this information may be often and is actually implicit, and it adds to the difficulty. No one states in the text that, for example, the act of kicking a ball, it takes 7 seconds, right, or milliseconds. It's just so implicit, but you don't write in a tweet, oh, I just kicked the ball and I did it for 1 second. But we should know that this action is very short compared to, let's say, I don't know, playing the whole soccer match, which we know how long it takes. And here I would say some researchers started to organize this temporal common sense reasoning field, and they distinguish 5 types of, I would say not directions, but maybe axes, 5 axes that you do this temporal reasoning. You reason about duration of events, you reason about ordering of those, how frequent they are, so you know that brushing your teeth should be daily at least, and the better if it would be twice every day. Stationarity, something like a sun is in the solar system, our sun of course, is stationary forever. What is a typical time? Again, brushing teeth, maybe in the morning and evening, but not so much, maybe in a lunch. I don't know what is the culture here, but in Europe, it's usually twice a day, and so on, right? So this kind of reasoning you have, and a very nice paper, influential, has interesting title, Going on a Vacation Takes Longer Than Going for a Walk, which for us is obvious, but for machines may not have been that obvious in 2019, and so on. And here I give you an example, and we'll sort of try to look what common sense reasoning knowledge, temporal, is there, right? So my friend went to Duke University, then he joined Google, and so on and so on. So you can read it, and then you say that, okay, he went to, we know it's a college, so we can say duration is 4 years. We know the typical time for it, 18 years. I guess it's same in India or similar. We know that, what is this? North Carolina. Bill in North Carolina. Yeah, he was also in North Carolina then 4 years, not only in the college, but also in the locality for years. Because you know that staying in a college, usually you have to live there, not like can leave the place and live 6 months somewhere else. It's not that common, at least. You know that Duke, this city, oh no, sorry, university is stationary in North Carolina. Of course, it may at some point change the location. New campus may be built, but rather not. So stationary. We know that he joined Google after, and which is not stated here explicitly. You don't have after, right? It just says with a degree, and from common sense reasoning, you need to know degree means you finish study, right? And then you can move to another place. Another job, so order is here. Then he attended 3 times NAB finals, and we know that the finals are every year, again, some sort of, well, we know we're humans, but we expect LLM or whatever the model you use to also have this knowledge, that this is a frequency, yearly frequency, and then attending basketball games is just few hours, rather not a day. And then few times is given here. Well, yeah, visit alma mater, we can say a few times a year, it's a maximum, right? And duration of each visit is this. So there's a lot of implicit temporal knowledge, as you see here, that we humans can very easily provide. Now the question is, can LLMs, you know, with a good accuracy, return such a knowledge, because they probably have it, but mixed with others and can output something confusing, hallucinated, and so on. But yeah, can we make sure? So the very well-known data set in this regard, temporal common sense data set, was by Scho, the same person, and he, according to those axes, provide many questions. And you see some questions are binary, yes and no. The other questions are multiple choice, and 2 allows, 2 choices allowed, then again, a multiple choice question. So you have a data set that have, I don't remember how many, but at least a couple hundred instances on each type, if not thousands. And now you can train, fine tune, but especially test LLMs. Are they good into reasoning on stationarity, typical time, duration, ordering, and frequency? Right, and here we, with Professor Saha and well, a couple of students, we proceeded to use this data set and a couple of others to test LLMs, and we were happy to publish a paper last year at EMNLP on this, how LLMs are good in temporal common sense reasoning. And until then, it was not studied. It was just a data set made and some, you know, simple models like BiLSTM, maybe RNN, but not LLMs. And then, well, this is just a, of course, motivation that if you have a good understanding of temporal context, that's not just good for answering questions, it will be for many other NLP tasks, beneficial storytelling, natural language inference, timeline understanding and creation, tracking user status. For example, in the times of disasters, and this is a good, I think, motivation, you want to know where each user have been. And you know, you might not say, now I am here. You might just say something like, I was taking a bath and then planning to do something. And by the temporal information, you can quickly reason where the person is likely to be, what is likely to be doing. For dialogue management, of course, and also for placing targeted commercials, right? In the Twitter or chatbot can recommend something. If a person stated that I'm learning a Python, for example, right? Well, yeah, I want to learn Python, for example, and I started learning. And then can we issue the course recommendation now? But it's also okay to issue course recommendation next month? Probably yes, right? You can say it's a bit longer. But if you say, I just started, I don't know, painting my bathroom, and bathroom is small typically, and then you can recommend a paint to sell, but not 1 month later. Painting bathroom is often done in a day or 2-3 days. And if the person says, I'm painting bathroom with my two friends who helped me, right? This context information even shortens the duration, expected duration. So context also is important. I will talk about it later on. And well, we wanted to know how LLMs are good at it. We know they are better and better in many aspects, also in common sense reasoning in general and arithmetic problem solving. But what about temporal common sense and so on and so on? So we had many questions. For example, I like this question. Dr. Porter is taking a vacation and here you need to supply a token, be able to see you soon, or taking a walk and be able to see you soon. You have to decide what to put here, will or will not. And this is, I think, based on common sense, the answer here in this story. Definitely temporal common sense. You need to know how long on average, and this is a probabilistic knowledge actually on this. We cannot say it's always 3 weeks holidays, at least not in Japan when I used to be. Holidays typically once a week a year, and that's it, and you have to be happy with that and plan your trip very well because it's every day so precious. Cannot just go by yourself to Europe, better if you organize it by some agency. Anyway, just anecdote. But yeah, and another task might be given this text, provide a correct ordering of events, another task, right? So we tested, we have these research questions, what's the general performance on this task? Are models, in particular temporal task, better or worse? We wanted to know which one is lacking, which is good. What is the challenge? Ambiguity of temporal expressions, how it affects model performance, how they reason about past versus future, longer or shorter time frames, in presence of multiple events, only one event. You can design a data set like you want, and maybe for your particular case, you need to design model, thinking ahead, what kind of is important to for the data set to reflect whatever you want, fine tune the model or test simply the model if it's good, you may need to consider. And then we picked up not only this existing data set, as I said, but also others. We collected many. This is the one created by us, this temporal natural language inference. And there is a big bench data set that has many different questions, but part of them, a very small part, is still related to time. So we picked it up. There is some small others, and here you have kind of comparison of these data sets. The task is often classification, but some of them are multi-class classification, some of them are question answering, some of them are natural language inference, different types of classes, different evaluation metrics, and what these 5 important basic reasoning axes are reflected by a data set, right? So MacTaco reflects all of them, and the rest is more focused on stationarity or typical time or event ordering, those different, types. And then typically what you need to do in this case, well, I still have just an example of things. So here you see a question about duration of event, how long was his mother ill, and it comes from, some kind of story here. What's the typical time? I don't know, that someone arrives, right? And it's evening here indicated, and this seems like coming to make a dinner, right? So you come rather early, not too late for the dinner. Then a stationarity, and so on and so on. So you have many here questions for a given stories, and we selected LLMs, larger ones at the time at least, the instruction fine-tuned, and also even code generation models, which were somehow fine-tuned to generate a code, and also the prompt was written in a style of a code. Just like here, you basically convert the natural language question into something looking like pseudocode, but well, it's just a still code to see if it helps. And then we tested also a few shot case, a chain of thought, and obviously 0 shot, and different parameter sizes. Anyway, there are many details for you if you are interested in the paper. Here are just results of different models on different data sets, a few shot, zero shot scenario. And we wanted to see how much few shot improves zero shot, right? So there is this a change in a percentage observed. And then we could say that GPT 3.5 was rather strong. Flanty-5, a small model, but performing well. Code generation models were not good temporal common sense reasoners, so will not use them in the future. Then we tested the model against those 5, different, well, 6 here even, because I think this is just general. We tested them how they are good, and we concluded that on even frequency they are good, on duration tasks are good. Maybe those information is just often explicitly stated in the text. But other aspects may not be so good. For example, if something is changing or stationary, models were not that good on that. That's this column, stationarity here. And we tested this conclusion over many models, right? And then for specific timings of events, they were also quite bad. So you can understand what the models are lacking, and often it results to what is implicit in a text collection, what is explicit, and also what requires some reasoning and what does not require. So it's a bunch of things here. And then we also studied about past and future. So you have some story and you ask a question about the past, but you may ask also a question about the future. What will be 30 minutes later that comes from this story, for example? Or will it be 30 days, something more related to this? And then we found that models were much better in reasoning on the past. Well, not much, slightly actually, than on the future. But it's not like guessing the future. It's not what I discussed in the summarization time, a couple of slides before. But it's more like from the story, something is obvious, not debatable that it will be in the future. But it's still, going towards the future. So it requires some reasoning. And the models were worse on that aspect. And here, when you have reasoning on different granularity, it was established that they are good at hours and days, but not so much if you ask, on seconds level. Not perhaps, was this lasting 15 seconds or not, but more like, about activities that were that length. So models are better in a maybe there's simply more data on these granularities in a training data set. And then many other statistics, I will skip them. Ambiguous versus strict and so on. And here is an interesting also study we did with researchers from Netherlands, TU Delft, and also Germany, was that if we ask LLMs, that's another style, but if we ask LLM the same question, but we relativize the year, so we just map it to 6 years ago rather than 18, you will see the drop in accuracy of different metrics. And this is on one model, but we tested on others, simply because this requires some kind of calculations. The models were just, worse on this, which was a bit unexpected to us, especially that for us, it's very simple. You can do that calculation. And we didn't increase too high numbers here. It was all often 2 years ago, 3 years ago, but the drop in accuracy was observable. 35% LLMs are worse when you change the absolute date to relative. So for a good prompt, when you ask about some temporal things, try always to use absolute date. And this was interesting because if we randomize the date, right, changing this to something completely different and still demanding answer to be the same, we notice that the drop is similar, 30% drop, right? So if you corrupt the question, the effect is the same as you would relativize, and we are talking about this blue part, corruption, as you would relativize temporal expression. So that was kind of, shocking. And also another thing we tested, that if you actually take a question and you shift this date to the beginning of the question and you ask the model again, of course, you do it in a way that there's no inference of a knowledge, you will get a better answer, basically, with an increase of 57%, 20, or something like on average about 20%. So it's also important to state the time early on and stated in absolute terms when you ask LLMs. And we are doing many more analysis here. Even one is interested, I can tell you more. We have actually a suite of, so we release a data set, which is this kind of testing suite, where you take, these years, relativize years, change the location of a year, corrupt the years with a certain only number of, lag or extension. Then you also do paraphrasing. You also ask about the date of an event, not about some attribute. And so you from a question about attribute, you make a new question about the date of this event. So we have a kind of a suite for modeling the robustness of LLMs to know how they are good in temporal reasoning. And that's under review, this paper. But let me now talk about temporal validity, because they may somehow relate to what you have also discussed before, the study we did here. So what is temporal validity? It's something related to common sense reasoning, but it's more on the level of just a statement, not one event, one action, as it was typically in the case of temporal common sense reasoning, how long it takes to walk with a dog versus how long it takes to walk, for a shopping or for the holidays. And it is also related to up-to-dateness information or obsoleteness. If you have tweets, are these tweets still valid, or already we can skip them? Or, can search engine return something that is still accurate? If I ask about economy of India and I get a result on the top, which has been written 1 month ago, I'm fine with that, right? But if I ask about the weather, current weather in Patna, I don't want to see anything from today, 2 days ago, right? It must be today, and even 1 hour. So this can also be for a good search, for recommendation, for conversational, of course. If you converse with some chatbot and you say, I'm going now to take a bath, and then, the chatbot should not ask you 3 days later, did you finish your bath already, right? Or something, But you can also tell, please inform me after I take a bath about something, and this chatbot should know when to inform, and many things. Fact-checking as well, temporal validity is important. So we started this research in 2019. We generated a small data set at that time, 1.7 sentences, and now the story was to tell how long, we just focus on this duration, how long the content will remain valid, right? So let's say you see a newspaper and there is a headline statement, Prime Minister of India is visiting Europe, right? And you know that the newspaper was published 1 month ago. So this statement, can I trust it or not? Not, right? Because obviously the visit of Prime Minister is no longer than a week. Well, sometimes maybe, but rather not. So 1 month old newspaper, you already can reject it. So a lot of reasoning happens here. And we provided some classes, hours, days, weeks, months, years, or longer. And basically source data, crowdsourced, labeled. And then with a Japanese institute, we extended this data set to a very large number with a lot of money spent on crowdsourcing to 300,000 data points. We publish it at CIKM, this data set, Common Sense Temporal Action Knowledge data set. And we just care more on a finer grade, classes, seconds, minutes, hours, days, or longer, sorry. And then, this is an example. And now what we think in the future, and this community is lacking, is to do a multimodal version of this data set. If I have, let's say, these two pictures about a room that you need to clean, you have the action stated. Now the question, which one will take longer, right? This or this, and it's a pairwise preference. Maybe we are not asking about particular hour number or minute number, but which takes longer. And it's obvious that this cleaning will take longer than this one. And I asked one student to do it, but somehow he could not finish. And I hope I can find someone to generate such images by LLM, or just pick up them and label them with human thing, not only about cleaning, but also cooking, eating, traveling on a road, which is congested, maybe middle congested, and no congested. And this could be useful for robots, for reasoners, agents, and so on. It could be basically any picture associated with some action to be done, and implicit is that human is going to do. But you can add a context with a help of friend, without a help of friend, with a car or with a bicycle, you name it, right? You can also pick it up. So I hope to do this at some point to extend this task, temporal validity or temporal duration estimation, to multimodal scenarios. And cultural aspects could also here be very interesting to study. And then we went anyway farther, and this was last year ECIR. Actually, this was a best paper award for ECIR conference. We now converted the problem into a natural language inference. So you have some sentence like this, reading my book on the bus home again, and then there is a follow-up sentence. Let's say another tweet issued by the same person, which says, oh, I just only have few more pages left and I'm done. And now the question is this follow-up statement invalidating the first statement or supporting? So is the action still ongoing? Are you still reading the book on the bus when this statement was issued? Or it already finished? Like I gave you example in the very first lecture, I talked about cooking, I think pasta bolognese, and someone says, oh, the water is still not hot. Or you say, yeah, it was very tasty and now I'm taking a rest. And implicitly the action finished. So the action was invalidated the previous one, or supported or neutral. So we created 10,000 sentences, actually from captions of images that were taken from another data set, and labeled them with crowdsourcing. Like example is here. It's a natural language inference task. You have two inputs, but you reason about validity of one based on information from the other. And here the solution, we actually use this huge data set, knowledge graph, I should say, called Atomic, which is extended recently, that gives you many relations between different actions. Like, for example, I don't know, you repel attack, then you may be tired, right, after. Or someone needs to attack you first in order for you to repel attack. So a lot of things. Also, some of the relations here were because after, so clearly temporal, very useful for us, others maybe not so useful. We utilized that knowledge base, and then we embedded the relations that are present in any input pair of sentences. So we have this kind of knowledge-based embedding using this, and also usual text embedding. And these two embeddings were later concatenated, but not only concatenated, we also calculated a sum of those and a difference. This is a typical style. When you have two embedding vectors, you can concatenate them, you can average them, you can compute difference on them, and the best is if you do three operations together, and this input later to the linear classifier layer, and then you have three classes to choose from. And then we had reasonably good results, especially because we used the trans-E model for the embedding to create from a knowledge graph. Whenever we added them, they were improving on other existing models, but some models were quite strong, like this self-explaining BERT model, but still we could help to improve. Oh yeah, there's a relation embedding that I didn't really explain. But yeah, let's move on, because we extended this task again with a master student, and that was published this year in ACL. Now the follow-up statement is not just nullifying, supporting, but it says, is the validity here increasing, decreasing, or we can't say any change of validity, right? So we use crowdsourcing, but we pay a lot of attention to make a very good data set. 5,000 sentences, and we think this can be good for a tweet stream where you have follow-up tweets, and then you want to know with a classifier, and that the follow-up tweet, only one of them may be perhaps changing validity of this, the rest may not, so you need to know which one yes. And now we can maybe change the validity, expected validity of the first. So let's say you are waiting for a doctor and I have a doctor's appointment in 10 minutes, which means I might have to wait for an hour. It's a kind of sarcastic sentence. And let's say follow-up tweet comes, TikTok, that's always so boring. No one ever tells me how long I'm going to be here. Well, they would say no change in expected validity of this action. And then here, the doctor was actually on time, so glad the visit is going quickly. Then you decreased this expected validity, right? And then here, the doctor got called away on emergency, will have to reschedule later this week. That's increased, right? And even if you have just the first part of the later sentence, you would still need to say it's increased validity. And then we noticed that many of the changes, because we had a couple of classes of the validity, not just 5, like seconds, minutes, years, and maybe unlimited, but much more fine grades, from 1 minute to 5, from 6 minutes to 10, and so on. Like, I think we had 9 classes. And then we noticed that the biggest change, let's say increase, decrease, happens between the neighboring classes, right? So from 5 minutes, you now extend to 10 minutes, but not from 5 minutes to 5 days. Obviously, it's not common. And this is this kind of delta to future, I mean, backwards, sorry, here, or, you know, speeding up or slowing down the validity. And data set, we put a lot of attention to make it very well, very balanced. A lot of here. And then we had some observations why this context alters duration, because sometimes occurrence time of an action is shifted, postponed. Sometimes the duration, the context alters duration or I mean, changes or shortens duration, but not the start time of an action. Sometimes it's implicit, sometimes explicit. So they were quite interesting here observations. We will, in the future, we will hope to have more insights here, but our student unfortunately left, so I can't continue with him. And then here was also observation how many events we have, like involving sentences involving multiple events or single event, how many involving state or action, and then, you know, what plays here. There's a lot of here, I think, to analyze in the future. We tested kind of a couple of models, Mistral, Llama, and also the stronger GPT-4 with some metrics. We also published, by the way, a temporal common sense reasoning survey, if anyone is interested here. Not only about this study, but in general. And we said that often models have this shallow reasoning based on some kind of shortcuts, which for us are not meaningful. So we have to make very strict evaluation to make sure the models are not operating on some shortcuts, just have really good understanding, and is more in the survey on that. And basically, yeah, reasonably good accuracy, but we could later make this data set even more challenging. So let's take a break now, because that's actually the last slide for temporal common sense reasoning. We take a 15 minutes break, and roughly we meet, you know, almost 11:30, a little bit before, and then I will talk about temporal information retrieval part, the last part for that. And if you have any question, we can talk after the break regarding this common sense reasoning or others. Okay. Let's go. I'll be back.
You taste it?
Yes, that would be very good. Thank you. Okay, so maybe we can start. I hope it's all okay. Well, I didn't change anything in the setting, so I think online is still fine. Okay. So yeah, so is there anything we should clarify about the previous part before we move on to information retrieval part? Any questions? Okay, so good. So I will have this last portion now about IR. Of course, everything so far was also related to IR, but now just want to show you some models on just purely only doing information retrieval. So IR has been a field for a long time going on. We have typically user input queries, keywords, questions, image, and often this input is underspecified. So it's very short. A search engine does need to do inference to understand what is the search intent of the query. And then return in a ranked order relevant objects, for example, web pages or documents. So information need is in the mind of user, may not be explicitly stated, may not be even obvious to the user. It's kind of some direction user might have. And we only have this short query that goes to the search engine, and intent needs to be guessed often. And IR is everywhere in legal search, question answering these days, RAG, of course, patent search and recommendation. And very common paradigm is retrieve first from a corpus, given a query, and then rank, right? So retrieval ranking. And for this retrieval, you often need a search index, right? So you need to index the documents to map keywords in the query, or let's say a vector of a query, two keywords or a vector of the document, and rank these things. This retrieval and ranking paradigm these days is also supplemented by a re-ranking stage, right? You may retrieve a large number of documents, let's say 1,000 relevant documents out of millions, and this 1,000 you can re-rank in many ways. So my students, for example, study re-ranking techniques where you can do more and with a more detailed approach for a smaller set of documents, which you could not, for example, do with million documents. So retrieve first and then re-rank is a common strategy. Sometimes you also generate content. In addition to retrieving content, my student now also overviewed what is better for the RAG. Generate context to the question or retrieve context for the question to LLM better answer the question, or a hybrid approach where you retrieve some part and generate still some part and combine the context for LLM again to answer a question. And he studied over many data sets. The paper is under review, but it says that hybrid approach is actually often helpful, but the retrieval is still very important. You can't just generate a context purely. Many things happened in IR over time. The older models like BM25, vector space, probabilistic reasoning, well, not reasoning, but matching, probabilistic matching, LSI, LDA, topic modeling, early stages, and then we have a bit more complex models, especially those using vectors like doc to query, like we had where to vec. We have also doc to query, and some neural learning models and large language models these days used for retrieval and also for ranking. You have different models, right, that you can employ. Rank SVM. We have this rank GPT these days. That GPT takes, let's say, 100 previously returned documents, passengers often, for a query, and now GPT is trying to re-rank them so that even better accuracy you have, even better precision at 5, precision at 1, and so on you have. Rank T5 is a similar. Lots of here happening, basically because retrieval is so important for LLMs because of updated knowledge that LLMs need to somehow have, but they were trained until certain cutoff. And because of the privacy, we don't want LLMs to learn everything. And also because of the sheer size of a training data that you would need to be able to answer any questions, right? And the retrieval comes at help in this case. And many retrieval and ranking models have been much now improved by having pre-trained this stage where you have these dense retrievals. We'll talk about it a bit more later, and pre-trained neural ranking models. So pre-training helps a lot. Web is very dynamic. We have billions of new pages, and 50% of queries, I think, every time unit, like months or so, are just new. So it's a kind of very dynamic setting of a problem. We also have some user behavior, like user typically looks into those portion of a search results page. It's a kind of skewed to the left and only beginning, and often there is a cutoff at 10. So the first return result is checked, the second, and then you see logarithmically you decrease, and even there is a strong decrease after 10 because it's like you have to click to the new page with results to get later, right? So there were many studies on this attention decrease on the ranks here, and obviously that's why we have search results sometimes, sorry, not search results, advertisements sometimes shown on the right but close to the top or embedded even in the list of top search results to make sure user is looking at them, right? There is a click-through rate, by the way, it's here. We have also the problem of adversarial scenarios where search engine optimizing engineer tries to put a page, for a given query, artificially up, although relevance may not be very high. And there's the whole industry based on CEO, how to optimize ranking for a company. It's a kind of borderline. Sometimes you may say they are, on the black part or more on the gray. Well, still a lot of dollars here. But these days, as I said, rather than building a complex pipeline of a search engine, just like here, that was used to be before, parsing query, keeping index, crawling web, many components, and we go into simpler model, like LLM is just one model. Query goes, query results come, and sometimes LLM need to retrieve content, but it's still a powerful component, a single component that does not need all those different portions of a structure that were before necessary. So we are simplifying LLM to answer queries, questions from user, or LLM with RAG to do it. Of course, for RAG to do, you still need crawling and retrieval, but anyway, a lot of simplifications happen. NLP is revolutionizing this field a lot. A lot of inventions, and information retrieval is actually a very hard natural language understanding task. You need to understand things to return them in a good way. One idea would be how to return recent content. You need to not only pay attention to timestamp, but also the temporal validity, expected validity of the content. You may need to return content that is readable, so again, understanding, and understand very well what is the intent of a user behind the query, and then match documents. So there's a lot of reasoning tasks here. What I want to talk about is these temporal IR solutions and the overall temporal IR. So many queries on the web contain explicit temporal information, like they might have, a date. 1.5% of it, you might think, oh, that's not much, but if you consider how many queries are there daily, this is a huge number, what people search. And many queries are implicitly temporal, which are, you see, these temponyms, as we said, that have temporal aspect. And there were many studies that have a bit larger numbers here, a bit shorter. And nevertheless, we can't just not care about time in information retrieval. There's too much there, right? And first, I will talk about the type of retrievals, and then I will show you the way how we improved DPR, and the paper is under submission, so not yet published, but I hope it will be informative anyway. So we had sparse retrievals so far, which are still being used, like BM25. And rely on a traditional term matching techniques. So you have a term in a query, you see if the document to be ranked high has also those terms, and there is overlap or not. You typically represent documents by sparse vectors, considering frequency of words, and then overlap is calculated often to calculate relevance. And sometimes it works well. Actually, it's very fast. That's the good point. And often people use still BM25, especially, or cosine similarity-based retrieval, as one of the retrieval types. But here we have better solutions that are more now dominant, which are so-called dense retrievers, that your vector, both for a query and for the document, is a short and dense, right? Often returned by, let's say, BERT or some transformer, or some solutions like LLM to vec, where LLM produce a vector. Then you encode queries and documents, and then often you calculate it by cosine similarity, how close is vector of a query to document, because it's well tested metric and very fast. And it's better than some semantic matching, ontology-based matching, and so on and so on. So let's see the question example. Who is the bad guy in Lord of the Rings? I don't know if you know the answer. Who? Okay, someone studied or watched this movie very well. So the context might be Salah Becker is best known for portraying the William Sauron in the Lord of the Rings trilogy. If we do, just sparse retrieval, for this question, we may say the document here, it's moderately relevant because one overlap happens, of course, not one term, but many, but it's just one foreground in particular. But here, a document like this may not have a high score for sparse retrieval because William is not the bad guy, not exactly the same characters you have, but we know semantically it is actually, right? I shouldn't say it's not. It is, of course. So dense retrieval will handle such a document better than sparse retrieval and assign high score to it, right? Because of the synonym issue. The bad guy is a villain, but it's not the same. So DPR is a very well-known technique for dense passage retrieval for ranking these days. Very fast, enabled by Meta, using vector database, where you take a question, represent a vector, and typically BERT is used, and you have embedding of a question. You can remove some terms if you want from a question, but typically not. And then the documents, perhaps news, are also represented. First, they are divided into passages. Often 100 tokens is the size of a passage. So a window, is dividing it. You can have varying length. Somehow 100 tokens is what we often use. It's not too small to have just sentences, but also not too long and capturing well. And then each one is represented also by a vector, but you need to indicate what are positive and negative passages for a given question when you do the training of the DPR. So you are actually modifying these embeddings to capture intents, to capture relevance very well, and then cosine similarity is often computed for a retrieval. But you need this negative, you need the positive. We often select some random documents from the same batch which are not containing the query terms as a negative. Negative without annotating them manually. And positive would be the ones that contain not only perhaps the question of the terms from the question, but especially answer, right? So they should have the answer, and negative passages should not have the answer and be some random documents, often from the same batch. Maybe you can also, play here that they are even dissimilar from the question or similar to the question. So you can alter the way how you select positive and negative. And you observe often differences on this selection here. We talk often about hard negative and soft negatives here to have a good retrieval. But that's a vanilla style. What we cared about, because we wanted to make it time focused, we care about questions that often have some temporal component, like a date. And we wanted to match documents high that are not only relevant to this content, but are also somehow aligned temporally, not only semantically to the question. So we propose several techniques to solve it. One technique is to embed a question, but before doing that, actually add a separation token, and after that, again, repeat the date from the question. So you basically indicate, you take the all content of the question here, but you add this separation content, and you also repeat again the date here and the question date. And this reformed text is now processed by BERT to generate embeddings, and these embeddings are supposed to pay more attention to the date, because you extracted the date. You can extract it by regular expression easily, or temporal tagger, although it's a bit slow. Rules would be faster, just a date, and you emphasize it, right, by repeating, and you also repeat it actually, so it's even more emphasized. And you do the same for a document, assuming you know a date where the document was published, right? So you know the date of a document publishing, and then you know also the date of each passage in a document is the same, right? So you provide to the end of each passage a separate token and the date of a passage. And you do it, of course, here assumption is that, first of all, the question contains the date, right? Often question does not have a date, but it's something temporal. So we are now extending it by all those techniques that you have seen about query focus time, extension, detection, document focus time to guess what is the temporality here without observing explicit date, and also do the same on this side. But now what we will just discuss is a simplified scenario where we have this date here explicitly given, and we also know the date of those documents and the passages. All right, so date as a token DPR is one solution. Another solution is date tag approach. So rather than repeating this year again at the end of the question and doing the same here for passages, we are only indicating tags to indicate, well, inserting tags to the content, both question and document, to indicate where the date is, right? We give at the front of a date indicator, and at the end, we do the same in the passage. And while during training, we are supposed that the model will pay more attention to those part of a question and those part of a passage because they are in a regular way sort of indicated where they are for the model. Another approach, very simple to process, you only need detection of dates. You can do it with regular expressions, 4 digits. The first one should be 1 or 2. In the simplest case, or you can have temporal taggers like we studied so far that could be slower but with a more higher recall, whatever you can use. But the approach that we found to be the best actually is a so-called temporal DPR, where we take separately question and extract this temporal component from the question and encode both by BERT, and then concatenate the vectors. And we do the same from the passage, extract a date, and let's say you treat it like a short document where this date is extracted, and it could be actually months and a day. We tested not only year, and you treat it as another document and encode it, and again, you have a vector, you concatenate this vector. There is a lot to study how to combine these vectors. We can average them, we can compute the difference, we can concatenate them, we can even do 3 operations and concatenate all the results. It's to be studied in the future. We only use concatenation as the simplest. And then you do the training, provided you have, of course, negative, positive passages. I will talk about it later on, how it's done. And then you extend DPR in this way. We had 2 data sets to study it and to fine-tune, to train, Chronicling American and Archival, with a different time spans. In the future, we'll also make more recent data set to care about months only, not years. So far, we only studied this. The size of those are 380,000. But we only care, as you have seen, for the cases where you have explicit both passages and questions. So the date must be there explicitly stated. It's, of course, a simplified case, a special case, but we started with it. And in the future, we'll consider all the remaining data as well. But now the sizes of data set are like only for those, second lines, explicit labeled lines. By the way, these 2 data sets we created from news articles. And here you have performance of different variants of DPR, the vanilla standard DPR, date token, date tag, and temporal DPR. If you look whether the answer is in the top returned passage, top 5 returned passages, so it's a top N recall essentially. And you don't answer the question, you just look into whether the question is appearing in the top results. And results are the best for this temp DPR solution. So we will investigate it further on in the subsequent studies and don't use the remaining ones. They have some improvement, but not so much. And we also studied other measures. NDCG for retrieval is often used. It looks into often graded case where you don't say this is relevant or not relevant, but you can have a shade of gray of relevance, moderately relevant, little relevant, fully relevant. And you score them also depending on the rank position, and not only within some threshold and considering whether the answers, I mean, documents are relevant or not, but what is the position of each document. Mean average precision is another solution to evaluate results. So we have validation data sets and test data sets. And what we studied here, how many negative documents we need to have for a positive document, and the number we found 5 is good. But we also generated negative documents in a different way, either randomly or from the same year as the question answer, as the question focus and the question answer as well, of course, or using different years. So there's a lot of here to study, and we found that depending on the data set, a different style may be useful for this retrieval. And then we focus on answering questions, not just returning, but I mean, relevant documents, relevant passages, but checking if you can actually answer a question better if you use these techniques than vanilla DPR. And we get quite good exact match improvement, recall better, a token recall here, and contains, which is a metric if the answer is contained in the output from LLM, because sometimes LLM will not give you exactly the answer, but will give you some kind of text embedding the answer. So you use also those measures. So this field is, I think, promising. We'll study much more and dedicate more, because often companies also have documents published at different times, and you may need to match question time to the document time. And then we also extended LLMs to be more time focused. We only extended the BERT, obviously, because it's a small model and well studied, but still BERT, as you have seen throughout my slides many times, is used extensively for many aspects. So if you have, let's say, BERT that is especially good at time, you can employ it to so many cases: summarization, classification, retrieval, timeline building, and so on and so on. And BERT, as you know, is trained on 2 tasks, pre-training task, mask language modeling and next sentence prediction, where you randomly select some tokens, mask them, and ask the model to predict what is masked. Or you try to say if a pair of sentences are the following, one is following the other, or just randomly matched sentences. These 2 tasks are in the traditional BERT, but then there were many variants like sentiment BERT, well, not BERT, but yeah, sentiment extension to BERT, where you actually mask tokens that are label informed. So they are positive or negative, indicating terms. So by this, you train a model to be better in sentiment task, or use mask not a token, but a span. So you basically modify this pre-training task to whatever you really want the model to be good at, right? Perhaps in finding a span as an answer, not just one token as an answer. Well, in many ways, but there were no time-focused BERT, and we introduced 3 pre-training tasks. One is time-aware mask language modeling. So we mask especially temporal expressions. Sometimes we mask a normal dates, not dates, normal tokens. Sometimes we actually leave temporal expression unmasked, otherwise the model will not generalize well. But a good amount of terms to be masked, some percentage, I think 30%, are actually masked with temporal expressions. So it's more time-focused, time-aware mask language modeling. Next task we have for a model when we do training to date documents. So we take this here CLS token, embedding of it, and use a fully connected layer to predict out of a couple of hundreds of months, because the data set we use was 20 years long. So you have a good number of months over there. So months granularity we use. And we also have a third task, which is temporal information replacement. So essentially we we actually looked into some solutions that propose it where they were shifting randomly some name entities, right? Instead of Stanley here, they put Brian Johnson, and the model was supposed to tell where is this corruption happening and where not, which name entity is correct, which is corrupted. We did similar case. We left some of the dates untouched, like yesterday, or some temporal expressions, but some of them we corrupted, like 93 to 2003, last December to November. And again, we asked the model, where is the corruption happening, where is not? And then seeing many data instances, the model was gradually becoming better and better, and this time-focused reasoning, time-focused, embedding generation as well. And we used a couple of data sets to test the models. We tested on timestamp prediction, well here, dating documents, dating news, then estimating event of event date. So it's not dating documents, but dating event is a different. And then also on question answering, we tested, which I don't show the data set here, but overall underlying data set was 1.8 million news articles. So reasonably good enough to do pre-training for the model. And here you have the results for event dating compared to just BERT or BERT fine-tuned on our data set, New York Times, and some state-of-the-art solutions or random guess, again, accuracy, mean average error for different granularity. And here's some kind of variance, but that does not really matter. We get quite high improvements. Error was decreased and accuracy was increased. The document time stamping also. Here also you have solutions which use this other search task, but temporal information replacement, but we found it was not really that helpful. So we actually dropped it from the final model that has only the two temporal tasks. And sentence dating, so not documents, but sentences, and temporal question answering. We actually could improve here if we use by time BERT instead of BERT. And now you may ask the question, why the name of our model is by time BERT? Just because we care about the timestamp, and we also care about expressions inside content, right? Both types of time, generation time and content time that we utilize here. And we now experiment, this is a journal we are now writing, with a variant, second variant of by time BERT, where we are also not only caring about time expressions, but any entities that are sensitive, time sensitive. So we also do name entities replacement, name entities masking, name entities corruption. And from the name entities, we only single persons, because we think persons in the news are the most dynamic. The location, like India, is always the same, right? The capital of India is always the same. Maybe headquarters of a company is also the same. But a person's partner, person's film in which it plays, often are changing, right? Or person's events. So we mask name entities progressively, not only masking temporal expressions, and we see how they can help in addition to pre-training tasks like dating documents, replacing time expressions for pre-training. We also do entity, which we think is time sensitive, and we replace it to better model Bring LLM, and we have quite good performance compared to by time BERT first version. Sometimes actually not better, but better when you use much smaller data for pre-training. So it's also cost-effective solutions that we have. A smaller data we use, and we get better results compared to many other solutions. So I explained by time BERT, how it was built, pre-trained. I also explained this temporal DPR solution here, where you concatenate the vector, semantic vector of question with the vector of a date, and you do the same on the level of documents. And then you select these documents in a time-informed way, randomly, but randomly from the same year as the question answer, or randomly from other years, or far away, close away. We have some solutions here. But as I said, we tested it on these two data sets, and I will very briefly explain how we constructed these data sets to give you later information how you can also generate large data sets. And one first data set which we published in SIGIR 2022 was this archival QA. It has 500,000 questions that answers had name entities, and that was created from this period, New York Times. We concluded that this was the first data set that was long enough at that time, and they have very large number of question answer pairs. And these are the example questions generated, the answers, and a paragraph ID. And this paragraph ID is very important when you generate question answering data set, because by this, your data set can be utilized not just for question answering, but also for retrieval, for training DPR. So whenever you make a data set, try to always provide a context from which a question was generated and where the answer is. So it's very helpful for training DPR models, retrieval models. By this, you are extending the usefulness of your data set. Archival QA has it, and it was utilized later by actually some other problems that we even didn't envision, like in Stanford, they utilize our data set for a continual training and updating models, because it was so long, so they could train a model on these and then pre-training on the next years to play with this cutoff time of the model. We didn't expect that data set can be useful for that, for continual model up-to-dating and different versions of the same model, basically those problems. But anyway, let me come back how we generated questions. So we fine-tuned T5 on squad 1.1 data set to generate questions. For answers, we just selected name entities. So the limitation of data set is that always name entities and answers. Someone might say that's not always realistic, but in the news, you may defend this assumption quite well. But from now on, we will use automatic generation of questions. We'll ask the model first to pick up a good answer and then make a question for this answer. So we will have some more intelligent component here. Okay, just this one we can skip. And what we observed that often the questions are ambiguous. So for this, for this question, who won the World Cup when it was held in South America? This is not a good question, because you have many answers. You have answer not only Brazil, because World Cup was held actually 3 times in South America. So you don't want to have such questions in your data set, right? At least not if you do open domain question answering, because then the model which you test should have many answers, and most of the Q&A models are still focusing on one answer, and it's already difficult enough to have a model with good answer and what to say about recall and precision of all answers. But anyway, if you detect which question is ambiguous or not, you may ask LLM at least to issue clarifying question. That's a research also, how to issue good clarifying question, when to detect the time when you need clarification. So for this, and also to make good data set, we need models to detect ambiguity. And here was the research we did also in this year. We built a temporal ambiguity question data set where question is labeled and temporally ambiguous or not. And we tested LLMs on detecting this ambiguity. And we found that it's not the easy task, because it requires a lot of knowledge over time. But with some good solutions, like we also propose, in addition to data set, we could have a bit better with a small model, small number of parameters. Well, reasonably small, let's say, rather large actually. We could have better results, but BERT fine-tune was actually quite good compared to much larger models. And then we have some kind of linear, first disambiguation of each question by adding as of, and then several linear loops here to pick up the smallest number of these disambiguation questions, variants, to judge if a question like this is actually ambiguous or not, right? And then this is temporal ambiguity, but someone can also study spatial ambiguity or some kind of other type of ambiguity. There was no work on that, so we use it to basically improve our initial data set, archival QA, which is here, to have this filtering module to detect ambiguous questions and remove them from the last stage. And we started with 6 million questions, but many filtering stages we had to arrive at 500,000 good quality data set. But anyway, we later studied something based on OCR questions, where we have OCR paragraph, and it's very noisy, but we ask LLM to correctly modify. And these questions are spanning much longer time. And you see many of these questions are quite funny because they were American newspaper, something like who was fined $1 fine by the major. At that time, dollar was big value. Or I don't know, something about, Indians, Sioux Indians at that time, that was from this year, from a different state. We made sure that every state has a good number of question and answers. Over time, they are like this. But what was very precious and novel in this kind of data set is that we could study what's the effect of OCR or raw OCR, OCR cleaned or raw OCR paragraphs. So we found that LLMs are very much confused if you don't have this noisy text to a big extent, and you need to clean it by post-OCR processing to answer correctly. And that was the first kind of data set for that study. Basically, I think we can, that's maybe the last slide I can show you. And now we are generating another data set which has 100 million questions, and they are complex temporal questions, which we generate from Wikipedia, something like, was this event having more casualties than this event? Or rather than giving the name of an event like World War II, we make it more longer description, like the war where Hitler was the attacker, right? And now LLM or whatever model you test should know that this is Second World War, do this mapping inference. So that's why we call them complex, because you have many of these stages of, solving information to answer. And this is, several orders magnitude larger data set than anything existing so far, and also have many varying levels of complexity, where we have comparison questions about events, comparisons about entities, comparison about time, counting questions, how many events, how many, let's say, earthquakes happen in Japan where more than 10 people died, right? No one can answer it because such an information may not be stated anywhere in Wikipedia, and often is not. Nowhere in the news. You need to do a lot of inference here. So it's complex and large. And we had a lot of stages here to generate these questions in a good way. What we found that zero-shot performance on F1 of many models is quite low. And you increase this performance adding many examples, right? Quite well you increase when you have longer and longer number of examples on each model. Few-shot performance is better. But some questions are really hopeless, like counting, very low level of answers, and counting, and comparison also not that good. So you try to generate difficult questions and you make them more and more complex. And that's, I think, the important now these days, not just have a new type of questions, but make them difficult, label the level of difficulty, make them complex. And of course, the size should be quite large, and also have the means to, the paragraph form from where they were created. So to test also retrieval models, how well the RAG can perform as opposed to when you have no context. And you can also verify as opposed to when you have true context, where you actually kind of cheat in order to have oracle results by adding the true context to the model. And then you have all the levels of performance established. So I will finish here because I think we are covering indeed, 2 hours. A quick time for any Q&A question answering, if anyone has. Before we conclude, I hope you could get some overview of many range of topics, of tasks and so on. Maybe some inspirations what to do for your own goals, for your own problems, how to go. Feel free to contact me anytime. I'm very happy to interact, to answer some questions. We can also do some work if you are interested. And I hope, this helped to spark some interest and give some insights to this field. Okay.
Yeah, hi, sir. Good afternoon. This is Ravi. So I have few questions.
Right.
Hello. Yeah. So as you have shown for information retrieval, like there is a question along with the answer for the data set, like what we trained, right? So suppose like if we are trying to build a small language model or anything like large language model for the code conversion, basically, like suppose we want to build a model, we can basically convert the Python code into Java. So is it like we have to feed that particular like code snippet of that particular Python related to that problem statement, and then Java, like how will it work with respect to that context?
I didn't hear everything very clearly because there were some interruptions, but correct me if I'm wrong. I understand you are asking what to input to the model when you are fine-tuning small model, right? And you do
Yes.
it on a code correction or code generation. What was the task?
Code generation.
Code generation. Yeah, and you want to do what? To train a model to be good at generating code, right? Right? Yeah. Okay, I think so. Well, there are many, I think, solutions these days for making code completion models. I didn't study it in particular, but well, from my common sense, I would say you need, well, if that was a question, you need many diversified types of code. You need a lot of code with many comments, so there is a semantics clearly explained to the model, and the task that the code is solving, not just coded in itself. And I think maybe even training on many different types of programming languages could help for each programming language to be good at. Well, I'm not sure exactly on this statement, but it seems to be found that the more you have diversified data for training, it helps usually. So why not for that? And well, I'm sure you have at disposal many already ready models because this is very well known task. Everybody, well, not everybody, but many companies, IT companies are working on it and using it. So maybe you focus on some more niche topic because otherwise, well, depending on the application, but you may have a lot of going on in that field, right? I'm not sure I answered exactly what you asked.
Yeah, that is what I asked. Yeah, thank you. Yeah.
Thank you. Thank you. Is there any other question? Yeah.
So the model time word which have explained, how the predicting was done. Like, what was the label? Like next word prediction. It was the tag.
Yeah, so there was no label. It was just in this time-aware masking. You basically change the masking strategy. BERT is just masking randomly some number of tokens. But now we said, okay, you can randomly mask some number of tokens, but in this randomly, you mask for sure 30% of temporal expressions, because normally they would be like 1% or even less. So the model is, trying to always look into neighborhood on this temporal expression and have very good understanding of the time in that case. And second task was to predict a date of a text. So it was trained on a dating task of news articles. And the last task in a version by time was masking name entities. And then we are also focusing on the relations now in the second version of the model. So you mask the word like before, after, and not only the date, and during, and so on, to even more. And we'll study more and more these effects here. The problem is that, these are just encoder models. So we want to do on a decoder only models, but how to do it is not clear. Maybe at some point we'll have a model, something like a small decoder only model that is fine-tuned towards time, not just simply fine-tuned, but the architecture, maybe temporal self-attention could be somehow modified. That's still left to be researched.
Hello, sir. I have another question. So, like mainly I work in insurance domain, which is based out in USA. So they focus more on like the fraud analytics. Like suppose someone had taken the vehicle insurance last year and they claimed a lot of amount, and basically company don't want to sell that particular insurance to that particular person or company basically. So they have been using graph database a lot. So here also, like if we see with respect to temporal information retrieval, basically using LLM. So is it like, can it replace that graph database? Here also, like we can ask certain question mentioning, suppose if we have mentioned, that account number also is there, like with like after proper masking, like can it challenge the graph database? That is what my question.
And it was like incidence retrieval, right?
Yes.
That you mentioned. What is this incident in particular?
So suppose someone had like last year purchased the insurance claim, and they basically simply like they claimed like with respect to accident, but the thing accident was not major, but they claimed for higher amount actually, and that is what like, and then suppose like wherever whatever the car workshop they have used, and that workshop is also doing fraud, providing some false information basically related to that. So those type of customers are basically blocked by, but the thing is that they use graph database to check. Suppose like last year I registered company by name ABC, but I am the director of actually. This year I have basically registered something new company, so that like I can make the fraud basically. So for that reason, yeah.
Okay. So when we trained Bird, we were mainly imagining task of news article collections and searching there and answering questions on the history. Your case is a short-term history, and it's more based on user actions and not so much on some events like Obama, how old he was residing, and so on. So if I were to enter that scenario, I would maybe pay attention more to the temporal common sense relations, like this ordering, stationarity, frequency, and perhaps propose a new variable in the text and build embeddings around those elements. So rather than masking just dates, you can mask anything like a frequency indicator, interval indicator, other types of temporal expressions than dates. I would do that, and then fine tune strongly on many data sets for temporal common sense reasoning. So it becomes more strong in stories and understanding the order in stories, temporal common sense, not just historical knowledge like we have in news archives.
Yeah.
That's one thing. And well, you mentioned graph databases, right? Also,
Yes.
for that, I don't know, but yeah, you can always, it's some kind of knowledge graph, I assume, right? So you can always utilize it as a context for answering some questions, but you need to know what to retrieve, what portion of the graph, the central entity to retrieve, and how useful it will be. Well, this knowledge graph probably have some temporal information embedded, right? So you may need to associate time to nodes, time to relations, sometimes maybe give atemporal relation, and this may be also extracted from a knowledge graph during the answering some question. Yeah. So I guess
it can be like integrated using LLMs as well as graph. Both, if we can integrate, then the information what we retrieve, that would be much more beneficial. That is what you are saying, right?
yes, right.
Okay. Yeah.
Thank you.
Thank you, sir.
So, Professor Saha, what shall we do now?
Yeah, so now we will distribute the certificate, and then there is a Like if you are willing to appear for the exam, like, I don't know, like that is the norm of the Gyan course.
The questions are not too difficult.
So easy, like it's only multiple choice. Even if you will do a random guess, it will be correct. Like not like SAT's common questions. It's not like these complex questions.
And not 100 million.
Questions.
Only 20.
Random guess and you will get 100 out of 100. 20 out of
No, 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 not like that.
20 out of 100. You'll be able to beat an 11. Okay, so we will start with the past tense distribute the certificate so that you should not misunderstand. The examination is the prerequisite.
Okay, so good afternoon, everyone. So we know we are at the end of this course. So first and foremost, I would like to say a big thank you to Professor Adam for sharing such invaluable knowledge throughout the course. Your insights have opened new avenues for understanding and inspired all of us to delve into this fascinating research field. Also, I would like to express our deepest thanks to Dr. Shiparna Shaha ma'am because of her vision and initiative in this organizing the entire Gyan course. So without ma'am, it was just an idea. And also I would like to express a lot of thank you to our volunteers who have worked hard throughout this course. And last but not least, all of the participants, because without your active participation, it was nothing. So it was just an idea. So thank you for making it real. And I would like to call Shiparna ma'am on this dais to distribute the certificate. We claps, yeah. Really? Okay. So, yeah. So, ma'am, I would request you to share some views. This is the point. Okay, anyway, ma'am, your point is much loud and clear.
Yeah, so first of all, thank you very much for coming here to IIT Patna and participating in this course. And many thanks for the online participants as well for joining us online. Yeah, so basically as I mentioned in my inaugural speech as well, so we are collaborating with Professor Adam for the last 6 years. Like there was a student, sir, so there was a student called Anubhav Jangra. So he was my bachelor student and he started working, I think he went to SAR's lab when SAR was in Kyoto, Japan. That time SAR was in Kyoto, Japan, and he visited SAR's lab as an intern. So, and that way we started collaborating. In the last class, I was discussing on multimodal summarization. So we started working in the field of multimodal summarization. Like that time, many people were not working in the area of multimodal summarization. So we were somehow pioneers in the multimodal summarization. Like we developed that multi-objective optimization based approach, integer linear programming based approach. We defined this supplementary enhancement, complementary enhancement. So all those ideas. Later on, Raghavendra joined our team. Then Raghavendra started working on how to make this summarization authentic. Like first we should check that whether a tweet is relevant or not. Like it will be a two-stage approach. First we should check the relevancy, and then if it is relevant, then only we should use this for the summarization. So yeah, so it was a long time collaboration, but we did not, like, this is the first time we are physically meeting. So yeah, it's a great meeting you, sir, that you agreed and you are visiting IIT Patna as a foreign faculty of Gyan. And you know, Gyan actually, it was a great initiative by Ministry of Education and also Government of India. And before pandemic, we already invited many of the foreign faculty members through Gyan, like Professor Andy Way of Dublin City University, Ireland. Then is Professor Sadao Kurohisi. He was also from Kyoto University, Japan. So there are very renowned professors who already visit. Eric Cambria, Professor Eric Cambria of NUS, NTU, Singapore. They visited us in IIT Patna for the Gyan program only. So, but after COVID, this is the first Gyan that we are organizing, because in between they stopped because of the COVID, there was no physical interaction. So there was no GYAN. So this is the second phase of GYAN that they started. And sir is the first one who is visiting IIT Patna. So many thanks, sir. And yeah, so I hope we'll be able to collaborate more and more. And yeah, we are continuing the collaborations and we'll collaborate more and more. And obviously thanks to all my volunteers, like, list is huge. Raghavendra, Deepak, they were always with sir. Then Salmishta, Sophia, Sagata, Probir. Yeah, so they, they all made it possible. Like without them, it is not at all possible to have these 5 days GAN course, like organizing everything, taking care of sir and etc. So yeah, so, and also we got support from IIT Patna, obviously, in all possible ways. Yeah, so thank you.
So I would like to call Ravi Kumar Mishra. Online.
Yes, ma'am. Hello.
Okay, so we'll send you the certificate. Please do send us your address, okay? Ravi?
Okay, ma'am. Is it like hard copy or something?
Yeah, so we have a hard copy. So maybe we can speed post you the certificate.
Okay, ma'am. I will email that.
Yeah, you just send us the address. Yes.
Okay, then Manjul Maya.
Thank you, ma'am. I'm dropping.
Manjul online. Okay. So we'll do the same. Shipra. You are Manjul Maya. Okay. Then Shipra. Ari तेरा मार्बल लिंक हुई स्वागत मुखर्जी पवन भापुनी Harshit Nidam.
Thank you for coming. Yeah, thanks for coming. Yeah. I will join. Harshit, you are not there. I'm there.
Satyavrat got Satyavrat, sorry. Aman Kumar Singh.
Thank you for coming. No, Aman Kumar Singh. Yes, it's good. Who will take your photo?
Ankit Kumar.
Thank you for this.
Nobody is clapping, mom. Pasi Shailendra. Rudra Chandra Ghosh.
Online.
No.
It's all the participants.
Oh,
Those two.
okay.
Okay, one.
Now, most wanted, Deepak Prakash.
Oh my God. Who will take Deepak's photo?
No, they are playing for
Deepak has an appeal. So you have to take him.
Okay, so next, Praveen Mandal. You also appear for the exam.
Sorry.
No problem. Sir, Praveen, all the foods in between.
Now, most talented Sarmisha Das,
Almost.
multi-talented.
Thank you so much. Thank you.
So now ask sir.
Yeah. So now I am requesting sir to say 5 minutes of speech or anything you want. तुम लोगों का छुट्टा है ओके ओके मैं देखती हूँ so
क्यों
sir
कहाँ छूट गया?
actually attendance में इनका नाम नहीं था so sir can you just say a few words है
Wait, for something?
Yeah, they have not listened.
Oh, okay.
So we have it. So maybe in the attendance sheet, their names were not mentioned.
Yeah.
But दो है two ना? He got. He received.
you received na
Yes.
okay
Oh, you received na?
okay so this is Abhay Kumar
No. Yeah, thank you.
now I would like to ask sir to say a few words regarding your journey on this proposal.
Yeah, so thank you for attending. First of all, it was nice to listen to many questions and see the interest. Of course, my biggest thanks are to Professor Silvana Saha for enabling it. We applied once for this program, we failed, and as I said already before, I was thinking we had no chance, but she asked me to try again, and it happened. So I'm very happy to be here, and I want to thank very much for all the hospitality. I didn't expect all this care for me that would be given. I'm taken from one hotel to one restaurant to a temple, and I don't have to do anything. Everything is so nice. Everybody is so friendly, so hospitable. Yeah, hospitable. Sorry, after many hours talking, it's not easy. To say words to express my feelings, but I want to express my also gratitude to all the volunteers. Rakhavendra, who is not present here, but also to Deepak, who was taking me off by car and going with me for a trip, and all the other members of the lab who helped me. I also enjoyed a lot to discuss. It's amazing how many topics and ideas there are. I only could understand some part because in Hindi language there were other ideas circulating during our meeting. So I would say there's a big potential, and the motivation level, I wish my students would have the same. I think there's a big potential here in Patna. You are already very well-established university. But if you will have many laboratories like Professor Sripana Saha, I'm sure the university would be very, very highly ranked in the world rankings. What I want to say that whenever you will be in Austria or at some conference where I would be, an AP conference or IR, feel free to reach or somewhere close to Innsbruck. And email me if you have any questions, want to discuss something or start some research. I'm happy to help. I wish you good luck with your studies, with your work. And also want to thank, of course, to the university for all hosting it, and for any other faculty members who are not present here, but who helped to organize this event. I'm deeply happy that I could come, and I got selected for this prestigious recognition and be able to do the course. So thank you very much.
Thank you so much, sir. It has been an honor to have you over here. Sir, so we can take one photo, like, with all the participants. Like, should I call somebody from outside?
Yes.
Yeah. Sir, you can sit here.
Yeah.
How do video is saying?
Yeah.
Raghavendra has come.
Yeah.
Oh my God.
This
So,
time.
yeah, Raghavendra, he has exam duty, sir. Today first half, second half. He was so busy in the exam duty. So why Raghavendra has only prepared the exam duty chart.
Oh.
And why Raghavendra you have taken on 29th?
We cannot have photo without, right?
Yeah, we cannot have. It is like missing modality.
The key modality.
Imputes Raghavendra's photo in the cover.
Do we have a photo?
Yeah, I
For Raghavendra's certificate we have to give, sir.
I'm not sure. I have to think about it.
Perhaps, ma'am, after the paper.
Yeah, there is some condition.
Thank you, sir.
Okay, please on. Follow. No. हमको पेजियन में पेजियन डेटा एनालिसिस से जैसे और কি করবো আমি কি করবো তুমি কি বলছো
Take up this.
Okay. You can do it. And पूरा आ रहा है ना पूरा आ रहा है इसमें पढ़ लो ना
हाँ मैम आज
इसमें अच्छा वो बड़ा बैनर नहीं आ सकता ना बैनर करना कम ना ओके ठीक है पहले उसके थोड़ा पीछे जाके लो ना थोड़ा पीछे जाके लो ये सब चेयर नहीं आना चाहिए हाँ ये अच्छा लग रहा है सामने चेयर नहीं आ रहा है ना थैंक यू सो मच
तुम्हारा एग्जाम तो नहीं चल रहा था ना कि हमारे ऊपर
नहीं पहले ना एग्जाम दे दो प्लीज ठीक है ना स्वीट वो पैकेट खाते खाते क्वेश्चन पेपर दे दो और स्वीट का पैकेट भी दे दो खाते खाते दे विल डू द एग्जाम ओ इसलिए मुझे नहीं आ रही कोई दिक्कत
So, not maybe getting directly
पूरा कौन से रूम
but you like to outside also see that happen every day.
Every day.
Almost always.
in which room I have the exam
शर्मिष्ठा मैम का एग्जाम ड्यूटी किस रूम में अभी या दीपक के साथ है
most likely 106
106
but I'm not sure मैम चेक करके
पहले एग्जाम को मैं तुम बोल ठीक है
sir asking whether they can use ChatGPT
no it's very easy MCQ exam
it's end of days
it's very easy MCQ exam
you do not have to worry I think you will be able to output from chat
you will be done in 10-15 minutes don't worry
huh
just for
ले लेंगे
No, no. Raghavendra is available. Like people wanted to have photo with Raghavendra.
Really?
Yeah, sure. Can you imagine? When Raghavendra will become faculty, sir, nobody will give us that. So we have to take autograph of Raghavendra.
No,
Raghavendra is already having
सर के साथ
college. Already leads.
Before PhD.
Before PhD.
Thank you.
We can only control his wife. We cannot control Raghavendra.
We have to choose a good wife that will control him.
Yeah.
What certificate?
Okay, so now what is sir's plan? Till Raghavendra.
Today, no one is free on.
No, Sagota wanted to have some discussion.
Oh, okay.
So don't worry, I can do something.
No.
We have also like Chris cars.
Yeah.
Tonight we can go.
No. Swarmishta and Sagota, they wanted to have some discussion.
If they want to take him somewhere, they can take him.
You don't have to, I can just say,
No, but we could just make some, I mean, tell me some place. You think I don't think anything in Patna?
just my own is tasty.
Sir, your other half student. Sir counts as 0.5, ma'am. Like under his tutelage, he counts as 0.5, me 0.5. So total one student.
Thanks.
So, do you want to go to Ganga Ghat?
Ma'am, but
no,
who will take?
Swarmishta and Sagota.
No, Deepak has second half invigilation duty.
But what is it?
It's
In Patna, you told na Raghavendra. That's what.
You go Nighty Ghat and Marine Drive.
tomorrow morning you can go, ma'am.
Okay.
Tomorrow.
Okay, so then, sir, you take lunch, and then maybe you can come to my room again
Tomorrow.
today.
Okay, today.
Today, and you can have some discussion. She wants to have some discussion with you.
Yes, sir, I will be there with you, so don't worry. If you need anything, I can.
No. She wanted to say, she told me she wanted to have some discussion. She
Sure.
just started her research.
Yeah.
She was developing some data set in the sports domain. Summarization
sports
data set in
domain.
the sports
So
domain.
was discussed.
Yeah, no, she has not discussed.
Okay, yeah.
She was a new student.
Is another student that wants to.
Yeah, she has just started, she just not told me. Yeah,
How can I come?
how can you come up with
Can I come
that?
in?
No, I will, yeah,
I can come by bicycle.
Bicycle.
Tell me which.
no, you will not be able to come. That is the problem, see,
I mean, she has something to discuss. I also do have a discussion with you. We can take.
yeah, but,
If you come by bicycle, you pick me up, I go with you by bicycle.
no, sir, house,
I like riding bicycle.
who will take us?
Sir, from the
Like right now, Deepak will leave him to guest house. Then who will go there and with him?
As I tell you, bicycle is perfectly fine.
He doesn't know.
no, I can, but actually, doctor has restricted me to use it because of my back pain.
Oh,
That's why.
well, in that case, we.
No.
Deepak announced, right?
Everyone's exam duty, like mine,
Yeah.
Deepak as well. So
Can we walk? Is
you
it
can
far?
go, you can go. No, it's not that far.
Yes, but I can somehow. I walk.
So you just send me on Google indication where to come and I come by myself.
I will
He
come
will
with
come,
you.
she will
I
come.
will come with you because I'm pretty much comfortable with walking.
Yeah,
Then-
you like working?
Yeah.
Let's never work. We can talk more.
He walks 10,000 steps a day, sir.
Really?
Then that's
Okay, that's very healthy.
But then she goes and eat biryani like yesterday.
You have to burn this.
So I'm just neutralizing all this, like the
Okay.
much of calorie I have burned, I know I can have.
No, but that's amazing. 10,000 steps. It's very good. Very good. I wish I walked so much, but I always use bicycle. Walking is even better.
Yes, and I used to also ride bicycle, but due to my back pain and all, so the doctor said you are not allowed.
Better
to
not,
do
yeah.
it. Yeah.
Okay.
Even I cannot sit somewhere for a long period of time.
Yeah.
Due to
Right.
the back pain.
But how to get me there first?
So,
Deepak will take you.
Ah, okay. And then you come. What time you will come?
Yes,
So, like I have no issues.
What
with-
time is now, by the way?
Right now, it's
12.
1 o'clock.
Yeah, so we have
You can come at 2 o'clock.
yeah,
2
sure.
o'clock. Okay, perfect.
नहीं है, तो चल रही है। Online. Except.
So we will meet.
Yeah, sure. In evening also, if you want to have. I will get 5:30.
You said that would be today.
No slides. No, I think. But they see your slide never leaves at 1:50. It's really you have AI वाला तो पीरियड चल रहा है हम देख सकते हैं आधा घंटा पीरियड का एक जगह चल रहा है आधा घंटा उसका आंसर हाँ हर दिन चल रहा है हम ट्राई कर रहे हैं yeah I was your slide from not different local period by around 30 minutes and then again that Lufthansa flight to like evening is also gets delayed by 60 minutes. I do that. Website can. Yeah. Possible. I think I think that 7 PM that's the safest. It's the safest one. Second, but it's the safest one. And instead of keeping you living at 8:30, you live one and a half hours before 7. Yeah. Yeah, that's 2 times. Demonstrating is getting better. Yeah,
And that is now in running. Oh, that was actually this it's too common for marks.
Oh, they really.
Yeah, that's it's 5 hours.
Yes, I. It's like you.
Yeah, I know it's a funny exam. Like you don't have to pick a lot, you have to get any content like get parts.
It's easy only, right?
Yeah, you say they want to be the mark. Give me the answer sheet so that I can say.
You eventually answer.
You know, foreign professor. We
should put down.
हाँ मेरे पास मैसेज आया है क्योंकि इंटरनेशनल फ्लाइट छूट सकता है तो बेटर है कि आप वो एयर इंडिया का अर्लियर फ्लाइट में रिशेड्यूल कर दीजिए ना बोलिए ना थोड़ा अशोका को नहीं वो एक्चुअली 7 उनका था पहले 30 वाला फ्लाइट एयर इंडिया का 30 का फ्लाइट है उसमें कर दीजिए
Then try to leave.
कल ही है लेकिन फ्लाइट है ठीक है तो ऐसे कर रहे मैं मेल करो तो ड्राफ्ट करो तो
क्या चीज
कि कौन सा फ्लाइट रिशेड्यूल करके कौन सा में करना है
अच्छा तो 7 o'clock वाला ना 8:30 का 7 ना
So there is a flight at 7.
Sure.
Is running fine.
That runs fine. अच्छा ठीक है बता.
Just use so. I will.
Just give me answer. That force they can. Huh? 18.
Some information. Thanks for it.
So sir, actually there is a type of 430 as well. What do you want? 730 or 130? 430. Huh?
And then sir, we have to wait for 7 hours. So that's okay.
Because I have knowledge, we can That's what I always do when I try.
Better than
And it late time. And, yes. Yes. We're just fine. I just need to go get it.
Let's see this. That is this one here. 4, 5, there is a flight. It will reach at 6 o'clock. And then 7, this is also on option. 7, 10 is also.
Once we extend, it's better to extend.
So now I have to have a ticket in this flight. 8:35. If I have to in this flight. Either we can book in here, 7, 10,
It's a question.
7, 10 or 4, 5. Which one you want? But you will reach by 6. Then you have spend the night, 1 o'clock.
I know, but I have a lot of worry, and I have a lounge car.
So is this okay? 4, 5 is okay?
Even enjoy it.
But the seat is that.
Depends on how I will manage it. Bigger.
No, it sounds very constant. But one, three plus get the drinks there. Drinks are there. Yeah.
I'm going to some shopping, you know, this.
Yeah. It's a bit very important.
That is going to give me a launch.
International vaccination.
No, because if we extend, I would think.
Yeah. It's to go in the afternoon. It's better. Like nowadays, there is too much fog in the night, so not to take this. Smoke in the night,
It's very.
So we need to promote video. So I will add and start.
Yeah, you will have a blog, you will probably.
After taking, we have exam. After that, I will. See, I don't get that. सर आपने एक बॉटल है तो नीचे से आ देना हम नीचे ले जाओ You can leave now. Okay, thank you so much, but please be in charge. वो करना पड़ेगा लेकिन हाँ उसे नाटक को नहीं होता हाँ खराब लगेगा मुझे लेकिन कल आप साइडिंग को होना चाहिए हाँ
But the moment is time flexible.
लेकिन वो होना मुझे पहले प्रॉब्लम्स
Yes, ma'am. After discussing.
सर आप पटना में वो सब देख लीजिए, गंगा घाट में वो आरती होता है, वही आरती आती है, अच्छा लगता है देखने में। पैकेज लिया
हाँ सर, चलो थैंक यू वेरी मच, बाय सर, बाय सर,
पैकेज की बात बाकी सुबह सुबह पार्ट को दिए दियो
मैडम वो फ्लाइट का क्या बात है, कितना बनेगा एयर इंडिया ना 45 ना मैडम 45 AI 408 राइट 45 हाँ ठीक है अच्छी है एक 4 48 4 5 4 हाँ फिर आगे नहीं
इसको बंद कर दीजिए ना, करेक्ट हाँ
सब चीज हो गया सर अब
पर वीडियो कॉल कर, थैंक यू सो मच। No.
सारा अनप्लग करके कहाँ रखा था ना? अच्छा, लैपटॉप आपका है? लैपटॉप किसका है?
कल को सुना हुआ सर
नहीं, हाँ है रखा हुआ, डाल के ला।
जल्दी कर
हाँ हाँ, केबल सारा छोड़ देना है ना, केबल सारा सब केबल भी हटाना होगा।
नहीं नहीं 4 5 वाला 4 5 वाला मैं आपको एकदम तुरंत भेज आपको।
हाँ
भेज दिया ना जी मैडम
ना इंडिया को नहीं है यार, इंडिया का ही है यार, इंडिया में नेशनल है ना, कल का
ठीक है, इसको फिर
हाँ तो 4 5 वाला 5 मिनट का 4 5 का जो टाइप 5 है
हाँ
नहीं इंटरनेशनल फ्लाइट नहीं चाहिए, इंटरनेशनल फ्लाइट चेंज नहीं करना है, सिर्फ डोमेस्टिक वाला फ्लाइट चेंज करना है ना, पटना टू दिल्ली 8:35 वाला था, ठीक है ना, वो मैं आपको सब नंबर के साथ देखिए मैं आपको भेज दिया, ठीक है ना, ये आप